This video reviews how to get an existing architectural Revit model ready for analysis in Sefaira. I'll use a version of Revit's Advanced Sample project, which has a number of common errors in it. I'll walk through how to check for these errors and get the model ready to analyze. I'm going to focus primarily on energy analysis here. We'll cover modeling for daylighting in another video. There are two big categories of issues we often see with Revit models. The first is modeling issues, elements that are modeled with the wrong family type or the wrong function type, and these are fairly easy to check and fix. The second set of issues are regarding plane counts. A lot of shading or glazing planes will cause the energy analysis to run very slowly, and if you have an excessive number of planes, the analysis may time out. So there are a few things that we'll cover that drive up that plane count significantly, and we'll go over how to address those. But let's get started with modeling issues. The first thing that we're going to do here is open up the Sefaira plugin and use Generate Views. This will create a color-coded view of the model, and we can check the entity interpretations. So you can see right off the bat that Sefaira only cares about wall, window, curtain wall, floor, and roof families. Everything else is automatically hidden in this view and is not used for analysis. Now the first thing I'm going to do, because I care about energy analysis, is switch from the daylighting analysis view, which is the default, to the energy analysis view, because that will hide some additional elements. Now here we can see that the different types are color-coded. Roofs are brown, walls are green, windows and glazing is blue, and floors are yellow. And one of the first things we see right off the bat here is this exterior area is modeled as a floor. The reason that's problematic is the floor area is used to calculate internal loads like occupancy, plug loads, lighting loads, and obviously this portion of flooring should not count toward any of that. So what we'll do is we'll simply select it, come to the Properties panel at the very bottom. There's an Ignore for Sefaira option. We can simply click that, ignore it, and that element now disappears from this analysis view. Now that floor was already split from the main floor element, and that was good. It allowed me to tag that independently. If, however, that was modeled as a single floor, I would first have had to come in and split that floor element. We often see that as an issue with balconies, for instance, that extend beyond the thermal envelope of the building. You may have to split those balconies into a separate floor element so that you can tag it as most likely a shading element. So speaking of shading elements, we also have a number of those in this project. These have also been modeled using a floor family, and obviously we want those to not count toward our floor area but be used for shading. So what I'll do is I'll go ahead and select all the instances of that element. Let's make sure it got them all. Yep. And then again come to the bottom of the Properties panel and click Shading for Sefaira and click Apply. And what you'll notice is that it's now changed the color of that element to this gray color rather than yellow, so we know that it is now being read as a shading element. One other thing to check, it doesn't appear to be a problem in this model, but it's roofs that are modeled using the floor element. In this case, the roofs do indeed appear to be modeled using floor families, which is perfect, but that's something that you should check. And the next thing we'll check is the exterior versus interior function type of walls in particular, as something that often is a problem. And to help solve this problem, you'll see two views that Sefaira has created automatically. Sefaira Walls Exterior and Sefaira Walls Interior. If we click on the exterior, you can see it will isolate only the exterior types of walls. And what you notice is there are a handful of walls here that are interior walls that have been modeled using the exterior function type. And the way to fix that is if we go to Edit Type, you simply change the function type here from exterior to interior, and then that wall will be read correctly for analysis. So I'm going to go ahead and make that same change to the other elements here. We have some curtain wall elements. Let's select all those, change the function type. There we go. So I have now hidden the geometry that was mistakenly tagged as exterior. I've reassigned that to interior. If you're not sure which one it is, the question to ask is essentially, is it part of the thermal envelope of the building, the boundary between interior and exterior? If it is, it should be an exterior type. If it's not, make it interior. Now we can also isolate just the interior walls and windows if we want to double check those. In this case, these all look appropriate. And one other thing that you should check on the geometry side are floor plates. One thing that can be very helpful is to create a view where you isolate the floors in order to be able to check them. One quick way to do that is just to duplicate one of the existing Sefaira views. Let's go ahead and duplicate this energy analysis view, and then open the visibility and graphics panel and turn off all of the family types except for floors. We'll leave those visible. Turn everything else off. And now we have a view that just isolates the floors and allows us to very quickly visually check that those are correct. You'll notice that the shading elements are still visible here because they're still floor families, even though we've tagged them as a shading element. However, they are showing up as a different color, so we know that they're being recognized correctly. Now, for very complex models, it can sometimes be hard to do a visual inspection like this. And one of the issues that we often see is very small floor elements, maybe the top of a parapet wall or a portion of a staircase. Those things can be hard to spot, and they can add up to problems in the model. They can sometimes cause problems with the zoning algorithms, for instance. And a way to check that is to create a floor schedule. And you can very quickly see if there are any small bits of floors that you need to take a look at. Let me show you how to do that really quickly. We'll go to the Analyze tab, Schedules, and in this case we want a floor schedule. So we'll go down to Floors. And what we want to see, what we care about here is the area. We want to check for some very small floor pieces. That's a good indicator that something is amiss. We probably want to know what level it's on so that we can find it if there is something wrong. And we should also check that to see if it's already been tagged as a shading element for Sefaira or as ignored for Sefaira, because in that case it may be okay. So here are all the floors in the building. You can see that there are some very small floors in this case, but all of those small ones have already been tagged as a shading element, so that's fine. The other floor elements are either ignored in this case or are our primary floors, so it looks like we're good. Okay, so that was the modeling issues. Let's take a look at plane count issues next. The issue here has to do with analysis speed. Each additional plane, and especially glazing and shading planes, add analysis time. And even if you never run into a scenario where a model is failing, the more you can simplify, the faster your model will run. So the following tips are going to be helpful regardless, just to make the energy analysis workflow as smooth as possible. We're going to look at three main culprits of plane count issues: curtain walls, window families, and shading elements. Now, the first and most basic thing to do is just to make sure that you're in the energy analysis view anytime you're doing energy analysis. And that's because this view automatically hides things like curtain wall mullions and interior partitions, which otherwise add just a ton of shading planes to your model. Now, if you have very deep mullions that you want to use for shading, the way to do that is to add shading parametrically inside the web application. And that also allows you to study the depth quite easily and look at different configurations. You'll note that the daylight analysis view does include interior partitions and mullions because that does have an impact, of course, on daylighting. and the daylight analysis engine doesn't have the same limitations when it comes to plane count. So let's look at one of the common issues related to curtain walls. If the curtain wall mullion cuts through the glass, then Sefaira will not be able to stitch together these different glazing planes into a single element, and instead you can quickly end up with hundreds or even thousands of individual glass panes, and that will significantly increase the analysis time. Here's how to check this. Let's go to our 3D view for this model. Let's change this to wireframe or hidden lines so that we can see things more easily. And what I'm going to do is go to visibility and graphics. I'm just going to hide the mullions really quickly. And what you'll notice when the mullions are hidden is that you can see that these glass panels are actually split with a gap between them. So this is a case where Sefaira is going to interpret each one of those as a separate glazing plane, and it's going to drive up our plane count limits. Let me go ahead and turn that back on, and I'll show you how to go about fixing that. If we select this mullion and we go to Edit Type, what you want to do is make sure that the offset matches the thickness. So the thickness here is 150. We'll change the offset to 150. And what that's going to do is it's going to put the entire mullion outboard entirely on the exterior of the glass. And therefore the glass won't be cut, and Sefaira will be able to stitch together these pieces into one solid glass panel for that portion of curtain wall. And we can confirm that again by opening up our graphics panel, and we'll quickly hide our mullions. And you can see now that those windows are adjoining one another very closely. Now, if you model with curtain walls a lot, one thing that you can do is create your own curtain wall families that have this characteristic built into them automatically, where the mullions don't cut the glass. And that makes it very easy for anyone in your office who's building a Revit model. If they're using one of those families, it will just automatically work correctly for analysis purposes. One other quick note on curtain walls. You'll notice that this curtain wall contains both glass panels and solid panels. Sefaira will automatically interpret those solid panels as solid. They won't have glazing, conduction losses, or solar gains through them. However, because of a limitation of the Revit API, they still show up as glazing in the Sefaira views. So if we go back to this energy analysis view, it's difficult to differentiate them in this view, even though they are being read correctly. Now, if you really want to double check that, or if that visualization bothers you, there is a workaround. And if you search for an article in Sefaira's knowledge base entitled Solid Curtain Wall Panels in Revit, you'll find how to fix that in the view and how to check just to make sure that they are being interpreted as solid. So that's curtain walls. Let's talk about windows. Let me go around here to where there are a handful of window elements in this model. And any individual window family is likely to contain hundreds of planes. And Sefaira will automatically simplify most window families, so these standard fixed windows are probably fine for this model. However, you should know that custom window families are difficult for Sefaira to simplify in many cases. And what Sefaira will try to do is translate any piece of geometry it can see into something, either a window or a shading element, and as a result you'll end up with a lot of planes, and if you duplicate that element many times across a building, you could end up in a scenario where the model is failing or timing out. And if that's the case, if you see a timeout or a plane count limit, one quick thing to check is your window families. And if it is a problem, you can go ahead and replace that either with a standard Revit family or with a super simple Sefaira window family. And Sefaira has actually created a library that you can use here. You can download it from Sefaira's knowledge base. And let me just show you. Let's say that these windows are a problem and we want to swap them all out with a Sefaira family. So I'm going to go to Insert. Let's go ahead and load that Sefaira family in. I've already downloaded the Sefaira fixed window family. And now what I'm going to do, now that they're in my model, I'm going to select all the instances of this window, and I'll simply swap it out for an equivalently sized Sefaira window family. A super simple Sefaira window. Well, it looks like I didn't pick quite the right size there, but you get the idea. We can very quickly swap it out. These windows are very simple, and so the model will just run very quickly. So last thing to check here on the shading, on the number of planes side, has to do with shading elements. Now the shading elements in this model are modeled very simply, which is perfect. They should work just fine. But if you have very complex custom shading element, that could cause a problem. If you have more than 500 individual shading planes, that will likely cause a timeout for your model. And if that's the case, you have two options. You can either remodel that shading plane as a simplified element, in that case, one thing that we'll get into in future videos is a possible workaround where you can use work sets if you wanted to maintain two versions of that, a simplified version and a more complex version. But I'm not going to get into exactly how to do that here. The other option is just to get rid of that highly customized complex shading element and instead use the parametric shading in Sefaira's web application. And that perhaps is the faster and simpler approach. The model will certainly run faster that way, and it has the added advantage of allowing you to very quickly test a whole bunch of different options parametrically inside the web application to find the best configuration for your building. And that really is the point of Sefaira, is that early analysis to help you decide what configurations, what options are going to be best. All right. So we've taken a look at all the element types. We have taken a look at glazing planes. This model should now be ready to analyze in Sefaira. I'm going to make sure I'm in the energy analysis view, and at this point I can either analyze it using the real-time analysis plugin in Revit, or I can upload the model to the web application for analysis there. Let's go ahead and do a quick analysis right here. And there we go. We have our architectural model that is analyzing well in Sefaira.